In the early 1990s, experts believed faster CPUs would define the next decades of computing. But one engineer believed the entire industry was looking in the wrong direction. His name was Jensen Huang, and his decision, considered risky at the time, would eventually power the artificial intelligence revolution. Today, Nvidia builds the chips that train the world's most advanced AI systems, but the idea that started it all began in an unlikely place. In 1993, Jensen Huang met with two engineers, Chris Malachowsky and Curtis Priem, at a Denny's restaurant in Silicon Valley. It was not the kind of place where trillion-dollar companies are usually born, but the conversation that happened there would shape the next 3 decades of computing. The three engineers believed something most of the industry was ignoring. Computer graphics were about to become dramatically more important. At the time, graphics were treated as a secondary feature of computing, useful for video games and visual interfaces, but not fundamental to the machine itself. Huang disagreed. He believed the future of computing would require a completely different kind of processor, one designed to handle massive numbers of calculations at the same time. So the three engineers decided to build it. They called the company Nvidia. But starting a semiconductor company is one of the hardest businesses in the world. Designing chips requires enormous capital, extreme technical precision, and years of development. And Nvidia was a small startup competing against companies with far greater resources. The early years were brutal. Several of their first products struggled. One of their early graphics chips failed so badly that Nvidia had to cancel it completely. Cash reserves were shrinking. Inside the company, the pressure was constant. At one point in the late 1990s, if their next chip failed, the company would likely disappear. Everything depended on getting the next design right. That moment arrived in 1999. Nvidia released the GeForce 256. The company described it as the world's first GPU, the graphics processing unit. Unlike traditional CPUs, which process tasks one after another, GPUs were designed to perform thousands of smaller calculations simultaneously. For rendering three-dimensional graphics, that capability was revolutionary. Video games suddenly became far more realistic. Developers gained new creative freedom, and Nvidia quickly became one of the most important companies in graphics hardware. But something even more important was happening. Scientists working on machine learning began noticing that GPUs could accelerate the complex mathematical operations used in neural networks. Without intending to, Nvidia had built the perfect hardware for artificial intelligence. In 2006, the company introduced CUDA. CUDA allowed programmers to use GPUs for general computing tasks, not just graphics. At the time, almost nobody outside specialized research communities paid attention. But CUDA gave developers direct access to the enormous computational power of GPUs. Years later, that decision would become one of Nvidia's greatest advantages. As artificial intelligence research accelerated, the demand for computing power exploded. Training modern neural networks requires enormous datasets and extraordinary processing capacity. Researchers discovered that clusters of GPUs could train AI systems dramatically faster than traditional CPU-based machines. Suddenly, Nvidia found itself in a unique position. The company had spent years building exactly the hardware and software infrastructure artificial intelligence required. Then the world discovered generative AI. When systems like ChatGPT captured global attention, they relied on massive neural networks trained across thousands of GPUs. Data centers around the world rushed to acquire Nvidia hardware. Cloud providers began ordering chips in enormous quantities. And the company that once focused on gaming graphics suddenly became one of the most important infrastructure providers in modern technology. At the center of this transformation stood Jensen Huang, known for his black leather jacket and relentless focus on engineering. He guided Nvidia through multiple technological revolutions, from gaming graphics to high-performance computing, and now, artificial intelligence. Under his leadership, Nvidia evolved from a specialized hardware company into a foundational platform for the AI era. Its processors now power research laboratories, cloud computing systems, robotics, and autonomous vehicles. Today, Nvidia ranks among the most valuable companies in the world. Its chips train the systems that generate images, analyze data, write software, and accelerate scientific discovery. Now powers the most advanced artificial intelligence systems ever built, and the consequences of that decision are only just beginning. For our next video, what story would you like us to tell about empires or icons? Let us know in the comments. And if you enjoy our content, don't forget to give it a like.